So the question here says, a rowing club has a large number of members. A random sample of 12 of these members is taken and the pulse rate, x beats per minute, of each is measured after a 30-minute training session. A 98% confidence interval for the population mean pulse rate, mu beats per minute, is calculated from the sample as 64.22 to 68.66. So in part A, find the values of the sum of x and sum of squares of x, like that. All right. For this particular question, we are going to make use of, first of all, the lower bound for the interval for mu. Okay, so that's 64.22. And we're going to say that that's equal to the mean. The mean is calculated sum of x over n. N in this case is 12. And that's minus the critical t value. The critical t value here, we're saying that's t, 11 degrees of freedom. And since it's a 98% confidence interval, if this is 98%, it means that we've got 1% in the tails. So the t value, we have a p value of, 99%. So basically 0.99. So this is, if we go to the formula booklet, okay, MF19, if we look for how many 11 degrees of freedom and 99%, we fall on this value 2.718. So 2.718. Yeah, 2.718. So that's what we are going to be working with. Let me put it up here. So it's minus 2.718, and that's going to be times S over root n, which is root 12. I'll call this equation 1. We also have 68.66 being equal to the sum of squares in x over 12 plus 2.718 times s over root 12. All right, that's equation 2. So if we say equation 1 plus equation 2, that's going to be on the left side, that's 64.22. So 64.22 plus 68.66, sorry, 0.66, and we get here 132.88. So 132.88 is equal to, here we'll add these two, and that's going to give us sum of x over 6. And adding these two will give us 0. So basically, the sum of x is going to be 132.88 times 6. And 132.88 times 6, okay, we're saying times 6 gives us 797.28. So that's 797.28. So that's our first answer. All right. 797.28 is the sum of x. Now we want to find the sum of squares in x. All right. So I'm going to take any one of the equations. I'll take equation 1. And from equation 1, we are saying that we have 64.22 being equal to the sum of x, which is now 797.28, and that's over 12, and that's minus 2.718 times s over root 12. So we can actually make s the subject here. S will be it'll be equal to 797.28, and that's over 12, right? And that's minus 64.22. And we are going to multiply both sides by root 12 and divide both sides by 2.718. Okay, I've just tried to make S the subject, okay, and utilizing the small space we have, right? So that's S. All right. Let me put it up here. And let's do the calculation for S. All right, so it's going to be ounce over 12, and that's minus 64.22, and that's times root 12 over 2.718, and that gives us 2.8294, 2.8294. So that's kind of like the value we're getting for S. Now we know that S, or S squared rather, is calculated as 1 over n minus 1 of the sum of squares in x minus the sum of x over squared over n, like this, right? So we can actually find the sum of squares in x, right? So this is the formula we're going to use. Let me put it on the side so that we have enough space to do what needs to be done. So we're just going to be making use of this, all right? Which means that 2.8294 squared is equal to 1 over n is 12, so it's 1 over 11 of the sum of squares in x minus the sum of x, which we got to be 797.28 squared over 12, like this. So this is going to mean that we can actually find the sum of squares in x, all right, by saying, all right, that's going to be 2.8294 squared times 11, right? And that's going to be plus the 797.28 squared over 12. So that's how we're going to find it. And I'm just going to create a bit of space here. So this is going to give us the sum of squares in x being, and then I'll use my calculator for this. All right, so I'll say ants squared times 11, and then that's going to be plus 797.28 squared over 12. And this gives us 53,059. So 53 and 59. And this is the answer here. And that's how we do it right here. All right, let's move on now to part B, and it says, state an assumption that is necessary for the confidence interval to be valid. Or so for the confidence interval to be valid, we are saying that we have to assume that the population, okay, the population is normally distributed. Okay. And we hadn't been given that information. So we'll take that as an assumption. All right. So that's how we do it for this particular question.